Okay, good afternoon, everybody. So, hope you're having a wonderful day. So, today I'm going to be giving you some tips for preparing an abstract and also some tips for coming up with a presentation title, because these are both going to be important steps for your next part of the seminar. So some of you have already been through this process once. Some of you, this might be the first time. How many of you, is this your first seminar or class? Like your first of the two? Don't be shy. It's usually a good idea. I know these things. Okay, we got a couple. Okay, good. So we got a good variety here. We got some that are from second, some for first. Wonderful. So I'm hoping that I'll try to give some tips for both groups that'll be helpful, because obviously we only got so much time, and I'm serious that I could talk about this for hours on end. So the first thing you need to know about an abstract is an abstract presents the main ideas or contributions of a document. That's the biggest thing that you need to be aware of. So, at least when it comes to the seminars, the big limitations you're going to have on this abstract. So it's a short written piece for usually a document, such as a research paper, or an abstract would be a description for a talk. The restrictions we're going to have here are 80 to 120 words, so no less, no more. And the title has to be no more than 10 words. So I'll be expecting you to submit this over your courses by the end of June 15th. So there'll be a submission on the Your Courses page that you should be able to type in your abstract and title. So make sure you look carefully at the word count, and if you have a supervisor, please make sure you run your abstract and title by your supervisor first. I'm trusting that you will go and get the 2 thumbs up from your supervisor. Excellent. So I want to talk a little bit about this process. Now, you might ask, Dan, like what you just described here, sounds like I would have to have a lot of substance to put together an abstract. And you'd be kind of right. So there's a lot of elements that go into kind of the creativity that comes to present to a reader an abstract. It could be both mundane, or it might be really that you have to get down and get creative with the way you might present your ideas. So the big thing when it comes to an abstract, at least traditionally speaking, normally an abstract comes after you've prepared or come up with the main contents of what you would like to present. So you think of it as a summary of what exactly is going to get presented. So in the case of an abstract for a paper, which oftentimes research talks are based off papers, so usually the context is that there is some paper that you're talking about. Or if it's just a talk, there might be a general theme that you're trying to bring together, whether it be multiple papers, or you want to cover one given topic or domain in your talk. The idea is just quite simple. You're trying to give me a summary of this. But the big thing that I want you to be aware of is that an abstract also can be helpful for guiding a presentation. So you can almost look like the abstract as a condensed form of, say, a research paper or the main structure of what you might have in your presentation. So the abstract serves kind of a couple purposes. One, to get you through to a close summary, but at the same time, it's also a vehicle to help structure your talk so that people know what your talk is about. So if they read your abstract, they have an idea of what you're talking about. And 2, it also gives you an idea of what they should expect. So keep in mind always your audience when you come up with an abstract and a title. So I'll talk more about a title towards the end, but most certainly when it comes to your abstract, as I'll mention in a bit, the audience that you're going to be presuming here is just your fellow classmates here, and anybody, I would just presume just a basic computer science background. That's what I would presume for the kinds of talks that we'll be doing here at the seminars. Now, obviously there's always the it depends kind of deal that we can have for given areas, and I'll give you some tips on how to mitigate that in an abstract description, as I'm going to give you an example where things get quite technical sometimes, and how you can still communicate the main ideas while not losing the technical aspects that otherwise would make your abstract next to impossible to communicate. So I'll be giving you some tips on this. So I must stress that there are a few documents on the course website that you'll find very helpful. And a lot of what I'm going to say here is relevant to this. It's relevant to this. So just keep in mind that a lot of what I'm going to say here is more of like a general rule of thumb, just meant to be a general theming, because different areas of computer science tend to have different kind of, I don't know if the word objective is the right word, but most certainly it's the goal of the research might be a bit different. For example, if we're doing more empirical research, the goal might be some research outcome based on some hypothesis. Or, for example, if I'm trying to test and see if there's a certain method that is applicable for some application in mind, that might be the gear or goal of the research. Or perhaps you might be interested heavily in adapting an application to solve some problem. As you can see, there's a lot of different vehicles for which somebody can communicate these to somebody. Likewise, I'll include the fourth because I'll be showing you an example of what I mean by this. Another one is that obviously people can also just literally present you just results, and they tell you, hey, look, at the end of the day, I have some neat result I would like to present to you. And it's just as cold turkey as that. And it's just a matter of trying to make sure you communicate those ideas clearly. So usually you'll find that the abstract is easy to break into kind of 4 pieces. So like I said, it's not going to be necessarily that it fits perfectly into these 4 always, but I think this is a good way of striving for this. So here's what I'm going to suggest. So here's a suggestion I have for when it comes to breaking down a presentation. Almost think of the things that you would like to present. So if you're not sure exactly what the overall picture of your presentation is, which is true probably for some, that you're still trying to figuring out what exactly you'd like to do your presentation on, this might help you kind of figure out what kind of goal you might have in mind with your presentation. So usually there's 4 main parts that make a good abstract, at least in my view, is that you have some introduction or motivation. Now, like I said, it's not going to be that it's always going to be one specific thing. This is just meant to be a guide to help. So how might you introduce the problem? How might you motivate what you're studying or what you're interested in presenting? So is this like a well-known problem, or is this something that is a novel problem? Is there a particular application that you're interested in? Is there some subject area that this talk will be relevant to? These are things that help motivate or introduce the reader of your abstract to what you're talking about. So, for example, if you're, say, somebody like me that's really interested in weird theoretical questions sometimes that are oddly fundamental, I might tell you and introduce you to the problem at hand first before I say anything. Somebody might do that. Likewise, somebody might also use this as an opportunity to give you a scenario for which their research would be relevant. That's another thing they might do. But keep in mind, just try to find a concise way to describe this to somebody. Like I said, it won't necessarily be that everything fits into one core bucket here. An introduction, believe it or not, I would argue is one of the hardest parts about writing, whether it be a paper or an abstract, is introducing who or what you're talking about. And sometimes having a very slick, concise way of introducing the reader to what you're wanting to talk about is often quite tricky at first. So by no means, if you're ever just not sure how to introduce it, maybe focus on these last 3 first. And then it might give you some ideas for how to proceed with this. So the next big part of an abstract description very often is a literature review. So to contextualize what you want to talk to me about, tell me a little bit about what currently has been done. So this is just meant to be just something rather short or brief, just saying, trying to contextualize. So contextualize, I mean, so if I give you some scenario that your research is relevant to, tell me about what has currently been done. Just drop me in. Just imagine I don't know anything about your research, or I maybe know a little bit about it, and I want to be able to say if I had a chair here, and what I want you to do is tell me how to sit in this chair and get an idea of where you are as the presenter. I think that sometimes it's helpful to view it kind of like that, where you're telling me, why should I care about this talk? I find very often the literature review can be a helpful vehicle for doing this, but it doesn't have to be. Sometimes the literature review plays a big role in the abstract's description. For example, if you're doing more of a topic-based presentation, maybe you want to talk about maybe like, oh, that there's like 3 main areas, or perhaps there's a specific problem you're studying, and there's the literature reviews trying to give you an idea of what currently is the big problem, or what is the competing method. The third part here, this is where you might propose what you might be doing with your talk. Like what methods, what ideas are you planning to present? So what's the methodology, for example? So here you would contextualize like, hey, look, based on what I've introduced to you, what has been done, this is what I am doing, or what this is stuff that somebody has been working on. And lastly, this brings us to so this is mainly where you give an idea of what you're doing. And finally, of course, telling you how you verified it and what are the main results. So the one thing I will warn you about is that sometimes the goal here is trying to present really what your focus is on. So if there's a lot of details in your results, maybe, for example, pick out the one that's the most important that might really strike an audience and say, oh, look, we show that there's this statistically significant effect based on what we are seeking. So something like that's really helpful to put in an abstract because it gives them some idea of what maybe might be of interest for the reader. However, if you have lots and lots of results, it becomes very difficult to summarize all of them. I know personally I've written research paper abstracts that are just littered with results, and maybe that isn't the perfect way of going about it for a research presentation, but perhaps it's appropriate for a research paper's abstract. So often in those cases, you might just summarize just the general idea of what you did, and that way you can think of it like you're giving enough information so that if somebody comes and sees your talk, that they can learn more about it. So that's the other big part of this. So you might ask, okay, so Dan, how exactly where do I go from my idea for my presentation to this, where I have these 4 buckets? So here's a big suggestion I have. First, obviously, think of what you would like to present. That's the first thing. Sometimes, and I'll tell you this from experience, you might have several things you might want to talk about, but you only have, especially with some of these talks, very limited amount of time, right? So you don't have all the time in the world to talk about everything. As much as you would love to do that, I'm sure some people in the audience would love to do that. But at the same time, you got to focus in on what you think would be the most effective to communicate. So for example, if you have several results and you just don't have time to present them all, you can either take one of 2 approaches. You can perhaps, I don't like to use the analogy of a shotgun blast, but you could shotgun blast all your results out, but in a broader way. Or you can more narrowly focus in on maybe 1 or 2 of those things and just tell them, like, oh yeah, you worked on some other things, but these are the couple of things that I wanted to focus on for this talk. Or you could take something in between where you talk a little bit about some of your results and you maybe focus on one thing. So you show a little bit of breadth and a little bit of depth. I usually find that that's kind of the one or better blend of a good and effective presentation is if you can kind of do a bit of both. Sometimes it's appropriate to do the shotgun blast. Maybe it's a bit more appropriate to be very narrow and specific. Sometimes it depends a lot on what you're presenting. The big thing that I will tell you is brainstorm what you would like to, what are you talking about? Try to brainstorm it. So try to come up with the list of things that you would like to talk about for your presentation. So whether if it's like a paper or if you're working on something and you want to present that, try to come up with a list of things that you want to talk about in your presentation. So that's what I usually do is I'll have like couple of pieces of scrap paper because I tend to write like a bad doctor. I write all scraggly. I'm like, oh, look, I got to talk about this, this, and this, and this. And then I try to estimate in my head, oh, could I talk about this? Could I talk about that? Nah. So I try to brainstorm what would make an effective talk. So keep in mind, what effective talk, it will largely depend on what ideas you wanting to communicate. So I'll obviously have a lot more to say when we get to actually talking about the presentation itself, but the best place to start is start brainstorming what exactly you would like to talk about. And then what I recommend is try to fit it into these 4 buckets. So try to find a way to kind of fit them into these. Now, for some areas of computer science, it's very natural to fit them in these 4 buckets, especially if, say, you're doing some research, for example. If you're doing some research or working on a project or something, you may have something that might perfectly fit into this box, these 4 buckets, because very often a research paper has 4 buckets that are very similar to this. Not every paper or area does, though. For example, what an idea of a proposed solution or idea might vary from more of an applied area to a more theoretic area. So actually, you'll see this in the example I'm going to give you later. But so far, are there any questions? I thought I would give you some good kind of basics before we get kind of into some meat and potatoes here. Are we all good to go? Give me 2 thumbs up if we're all good to go. Okay, well, what I'll do is I'll keep going here, and let's talk a little bit more about the preparation of an abstract. So imagine you have an idea for your topic, and you have some ideas for how you might proceed from that. So trying to put it into these buckets, at first it sounds really simple, but you're going to see that if you focus too much on the limitations of your abstract's length, it might actually be a bit more challenging at first. So I'm going to give you some advice for how you might go about this. And I will tell you, it does take time to sort of get into that mindset where you think of these caps on words and how you might concisely describe these things. It's not just something that clicks overnight. I know that it took me a long time. I used to be quite a verbose writer. Now, I had to learn really hard to not be as verbose. So I thought maybe it might be a good idea to go through an example. This is actually from one of the documents that are on the course website. I thought it would be a good idea to get into the idea of how we can identify the 4 parts of an abstract. And this will be something that will be helpful when, say, you're submitting yours. I'll be trying to identify roughly these 4 categories. Now, it isn't going to be perfect by any means, but most certainly for a lot of areas, it might be easy to do. Other ones, not so much, but I'm hoping that I hope this exercise will be helpful for us. So what I'm going to do for dramatic purposes, I'm going to read this example to you. So this is an example abstract. It is of the length that is required. I did not make this abstract, by the way, just to be very clear. I don't work in this area. I just thought it would be an important idea to just show you a good example. So let me read this in some dramatic voice here. Attack damage cost and privilege escalations evaluation play a critical role in selecting the right countermeasure by intrusion response system, or IRS. Existing attack damage cost evaluation approaches inherit some limitations, such as neglecting the dependencies between system assets, ignoring the backward damage of non-goal services, or omitting the potential damage toward the goal service. In this paper, we propose a defense-centric model to calculate the damage cost evaluation by considering not only the damage services, but also the potential damage towards the attacker target. The model has been implemented, but is not limited to, the cloud environment and tested with a multi-step attack scenario. Now, I'll be frank, some of this stuff I don't know. But here's the thing. The way it's structured is in a way that I should have a good idea for what, if I were to say attend this talk, I have some understanding of what some of the things in this talk might be about. I could see that something about security, for example. But the thing here is I would like to show you where these 4 buckets are. In fact, I would like to get your help to figure them out. So I'll give you a tip for where we can start here. So there's kind of these 3 buckets I have here. So I'll pick off the easiest one for you. So in this paper, so they talk about a paper. In this paper, we propose a defense-centric model to calculate the damage cost evaluation by considering not only the damage services, but also the potential damage towards the attacker target. So notice in this sentence here, they lay out, for example, a proposed solution or idea and an approach. So usually the easiest way to signal this to a reader is saying, in this talk, we'll do blank, or perhaps in this paper, we will do blank, or we consider blank. Very often, it's some way of getting there, but it depends a lot on the context, as we're going to see in my second example here. So what I'm going to do is I'm just going to make this a little easier for us to see what's happening here. I'm just going to underline some parts here. So if I were looking at this, I'd be like, okay, well, that seems to be talking about the proposed solution or idea and an approach, right? It describes some approach for doing this. Now, remember, I didn't write this abstract. I'm just trying to give you an example. So the point is that I don't necessarily even know everything about this talk. But the thing is, I can still identify what they're trying to propose in their presentation, right? I see that they're going to be talking about this so-called defense-centric model and talk about how it can incorporate some things that are currently not good enough in some of these other things, these previous models. So I have a question. Now, where would you think is probably the best place to see where the intro or motivation is? Did anybody have any ideas of where the intro or motivation in this abstract is? Any ideas? And I must stress that not necessarily is it going to follow this exact ordering, but it most certainly, you'll find very often it flows nicely if you do, but most certainly it doesn't have to. In a sec. Okay, so we have this first sentence. So there's this first sentence, then there's this one saying existing attack damage cost evaluation approaches inherit some limitations, such as neglecting the dependencies between system assets, ignoring backward damage of non-goal services, or omitting the potential damage toward the goal service. So when I read this, I don't necessarily sure that you can think of that as a motivation. Like I said, it isn't going to fit perfectly into buckets. I do see exactly what you mean here, though, because it does sound like there's an issue with this, right? So in some essence, it's kind of like a motivation for the research. But most certainly, it also is telling you about what has currently been done, right? So what I think, so I do like that suggestion, just for the sake that it is actually a motivation to do this research. But most certainly, it also tells you what's happening. So what I'm going to do, just for the sake of discussion here, is I'm going to put this sentence, the one you pointed out, I think this might be appropriate to put under this literature review kind of banner here. Because I think that it tells us about what has currently been done, but most certainly I like your idea, though. I do like I said, you'll find that very often when you're preparing these things, it's not like it'll fit perfectly into these 4 buckets. Most certainly, you can see how this would motivate some research talk. And I think that is actually a very good way of motivating it, right? You could say, hey, look, there's this issue with the current work. Here's how we're going to address that. But like I said earlier, you can even look at the literature review like a vehicle to help communicate, or even, I don't know if the word boast. I don't think the word boast maybe is the greatest word, but most certainly it is a word that, it's some way to leverage what has currently been done to highlight your own work. Whether it be your own work or what has currently been done or what has been changed in the research or something like that. I think that you can use often this number 2 here, the literature review, as a way to almost catapult your research and say, hey, look, I'm doing this. I'm doing this. So that's why that's why I made that suggestion, is that sometimes addressing the literature sometimes can be actually kind of helpful to attract a reader to come see your talk. So I was going to suggest that maybe we throw this sentence. Actually, I'm just going to put square brackets here because underlining it, I worry I'm just going to absolutely destroy everything on the board. So I'm just going to throw this under literature review just because it seems like it's talking about what has currently been done. Now, depending on how narrow your work is, sometimes the literature review, like what you say here, might actually be something quite explicit or very exact. For example, if your research is addressing something that a paper specifically did, perhaps you might even mention that here. So like in recent years, so-and-so et al., that's 3 or more authors, proposed a model called blank that did X, Y, and Z, that guarantees this following result. And then you could say, hey, look, well, using the same model, we achieved this better result or something like that. So in that sense, you can see how you can use the literature review to be very, like this part that I'm colloquially calling the literature review, as a way to kind of pivot, but also catapult your research so that it highlights it. So that's number 2. You can see quite quickly what the other 2 are. You can see that this is just introducing you to the scenario, right? So it's talking about something about attack damage costs and privilege escalation. They play a critical role in selecting the right countermeasure by intrusion response system. So this is just introducing you to what is going on here. So they talk about this attack damage cost. So this would probably best fit under 1. And this last sentence here seems to be talking about the validation and main results. So the model has been implemented, but is not limited to the cloud environment and tested with a multi-step attack scenario. So this is talking about what they did. So this might fit better into the last category. But like I said, use these 4 buckets, these 4 categories: introduction, motivation, literature review, proposed idea and approach, and of course, validation and main results. Use them sort of as categories to help you kind of figure out what you might want to present, because it'll help kind of organize your thoughts when you're brainstorming. Because sometimes it's not really clear, like the guide for which you want to present. Because I know that's for some people, like presenting stuff is a rather new thing, or if you have some experience doing this stuff, whether it be sharpening up that skill to do more presentations, or perhaps it could be just simply, hey, look, I've never done this before. How can I kind of organize my thoughts? And I think usually brainstorming some ideas for what things you would like to present and trying to structure it around these 4 points might be very helpful. One tip I do also want to give you is that when you talk about validation and main results, like I said, you can also talk about, say, either, say if you're talking about a given implementation, you might try to sneak something in here, such as like, oh, and we had a high confidence in our result or something like that. Obviously, you have to be clear and accurate to what you have as the results, or the results in the given results you would like to present. Obviously, don't mislead the reader. That is the biggest thing you should avoid doing, because they'll show up to your talk and be like, it's like, hey, this person said that they're going to do this, but they never did it. And they might be a little disappointed about that, or they might start asking you questions after and you might not have the answer for it. But yeah, are there any questions about this example? So I thought I would go through this just to kind of give us some flavor for how we might approach this act, kind of thinking about kind of organizing our thoughts in a very similar way that somebody might do the same thing with a research paper. So just to give a good idea of what I mean by brainstorming, for example, if you have a setup, for example, if you're doing more of an experimental work or you're interested in something a bit more experimental, you might make some like bullet points off for yourself. Okay, this is the setup for the experiment. This is what we were trying to evaluate. This is the idea that we had. What is it addressing? You could think of this almost as a brainstorm, and then what you do is you take those ideas, you try to refine it down from there. Because remember, 80 to 120 words, it's not very much, depending on how much detail you'd like to go into. And there's definitely a bit of an art to this process of cutting things down. So I thought I would give some helpful advice. So are we okay with this example? Give me 2 thumbs up if you're okay at this stage. Okay, excellent. Yeah, if you have any other questions or anything, don't hesitate to stop me. I've just gone mad with power here. I'm just joking. So I thought I would give you some tips for how to approach this. Because, like, it's easy enough for me to show you an example of an abstract, but you notice that this example, even though I don't know much about this topic, I was able to identify some key parts of it, right? So that's a good hallmark of an abstract that is clearly communicated. But it's not very surprising that that would be the case, given a lot of scientific or technical talks will very often fall into these kind of categories here. So I thought I'd give you a few tips before we proceed to our next example. So just a few tips I want to give you. And this is, I'm telling you, don't think that you need to first just think of 80 to 120 words at first. Sure, though, that's like a ballpark where you would like to be. But one thing that I can recommend, maybe start off with writing the perfect abstract. And I'm going to write perfect in quotation marks. So obviously keep in mind the restrictions you have, but start off by writing what you would like to communicate. But keep in mind that at the end of the day, you will want to get it down there at some point. But usually from conference to conference, or perhaps even seminar to seminar, or perhaps just like here, they may have different restrictions on you. But you know ultimately what you would like to present at the end of the day. So maybe start off by writing a perfect abstract. Don't worry so much about getting clearly within the confines of the restrictions here. Sure, try to ballpark it. Obviously, don't write a giant, like 3 pages or something. You know that that's way too long. But some people, it's really important that you kind of just start off by just trying to write it the best way you can until you're very proud of it. So I mean, to the point where you just like, man, I love the way I wrote this. I know that's really weird to hear sometimes, but most certainly you feel really accomplished when you try something for yourself and you really kind of figure it out. The other thing is that you do not need to give all the details away in your abstract. You do not need to give all the details away in your abstract. So the big thing with your abstract is communicating the main ideas. So focus on the main ideas. That I know this sounds really obvious, but I am telling you, I've given talks where I would like to have presented like 10 different results in it. And it's very frustrating when you can't just say like, look, we did this, we did this, we did this, we did this. And like, boom, boom, boom. With this kind of length, you're not going to pull, like it's not going to be either a very engaging abstract because you're going to have to dig so quickly into jargon that it's very hard to follow what exactly is being talked about. But the other thing, and this comes back to my example I gave here, well, it's technically not my example, it's the one from one of the documents we have on the site, is be only sufficiently comprehensive. So give enough details. So if somebody were interested, they could find out more. There's this phrase very often in science communication that you don't have to say everything. You have to say sufficiently as much necessary to help your audience understand what you're trying to say. So, for example, in that example we had, we know things about like vulnerabilities and attack approaches and things like that if you think of it more from that side. But most certainly, I didn't understand everything in that abstract, right? But the point is that you're being sufficiently comprehensive. So meaning that when you describe in your abstract something, if it's, for example, if our audience is a general kind of computer science background kind of audience, sorry, I got very excited there. If you know your audience is a general computer science one, you should expect that they are prepared to be able to accept something, whether it be a technical jargon term, an algorithmic technique. Things like this are things that a computer science-oriented audience might be considerate of or interested in. But the thing is that if you find yourself really needing the space in your abstract, you can trust your audience if you give them enough details to try, if they really want to know more about it, they can invest that time to find out a little bit about it before they come to your talk. But the other thing is that you're going to find that you're going to need to cut things if you were to just start off with the perfect abstract. So when I say perfect in quotation marks, I mean like you've written it very carefully, you've included everything, but you'll find that very quickly, if you're trying to meet restrictions like that, and this is something that almost every prof I know will go through this process at some stage in the year at least. I know other grad students that did when I was not a grad student, is that you have like, oh, I need to chop 20 words out of my abstract, or I need to fit this onto 12 pages, but I have 14 pages. And then you have to sit there trying to figure out what you could do with it. So instead of looking at it like a negative, think of it as a positive. So if you take my advice here, try to think of how you can cut details from the abstract in a way that you can cut down that word count. For example, if there is a word that you see there that isn't necessary to be there in the sentence, so that obviously you want to make sure that the sentence is still comprehensive and grammatically correct, but most certainly if there's a lot of filler words or words that aren't necessarily filler but just redundant, you try to find ways to axe these things so that you can only focus on the parts that are sufficiently comprehensive. So if there's some things you want to talk about in there, you can try to trust your audience to understand what you're talking about a little bit further. You'll see in my example what I mean by this. Finally, of course, always check your spelling and grammar. This is something that, again, very obvious, but it slips the mind sometimes. One last tip, of course, is to get somebody to read your abstract. So, for example, if you have a supervisor, have them read your abstract. If you got, say a brother or sister or parents that are willing to read your things, or say somebody you're living with and they're willing to read what you've written, and you want to get their opinion on the way you've written it. I encourage you to do this. Have somebody read your abstract. So whether it be a friend, your supervisor, family member, significant other, whomever, you can trust to read your abstract. Obviously, don't send it to somebody just randomly. You should send it to somebody you trust, especially if it involves original research. So just remember, if you have a supervisor, please make sure you run your abstract by your supervisor. Make sure you get the 2 thumbs up and you say, that looks great. That looks great. So these are some tips I have here. You're going to find that this tip right here about being sufficiently comprehensive is going to be relevant for our next example. You're going to see why. But are there any questions about these tips? I'm trying to give you some broad kind of general advice for how kind of the thought process when you're going through this. Because I know that this step sounds like, okay, so like, what do you mean by that? So don't forget, you gotta, if you need to cut things, cut them. Be sufficiently comprehensive. Get the things that are necessary for people to understand what your talk's about. If at the end of the day, it's about choosing between, do I write this lengthy explanation about this one thing, or I can leave that for the actual presentation, but present to you just the general idea of what we did, Perhaps you may have to make that cost-benefit analysis in your head, like which one is more important. So if we're okay with this, give me 2 thumbs up and we'll proceed to our next example. I thought I would show you an example of what I mean by once you have a perfect example, what can we do with it? Like how do we do this whole cutting thing? How do we cut things down? So I will warn you in advance, this entire board's filled with words and I will read this to you. If you find yourself wanting to like read this over, I actually have it in that document on the course website. If you want to look at that instead, I will walk through this and we're going to go through this together because I want to make sure you can see the kind of the mentality that somebody might go through to try to cut things down. And the other reason why I want to show you this to you is because for some of you, whether it be that you already have some research, you can think of this as a general talk that I gave. Actually, I've given this talk at least a couple of times, a couple different universities. I gave it maybe the late 2010s, maybe like somewhere about the middle there, 2017, 2018, something like that. And this was meant for more of a general computer science audience. It was not necessarily a graduate level, but most certainly it was meant for more of a general audience. So I didn't necessarily know what my background was for my audience, except that they knew stuff about computer science. But it was a public talk. So the first thing you should notice right away, other than the fact that my writing is just all sorts of all over the place, is that this looks a lot longer than what I had over there, right? So first, I'll give you the title. The title is Approximation Algorithms for Scheduling Unrelated Parallel Machines. So the title seems okay. It's definitely no more than 10 words, right? So that's okay. But there's a bit of a problem with this abstract. I'm guessing you can clearly tell that this is not going to be within 120 words. It's something like over like 200 something. So let me walk you through the abstract, and we're going to go through the same exercise of identifying the 4 pieces. And here you're going to see that the buckets are not going to be as clear as well. So I'm just trying to illustrate that it isn't going to be like this orthodox thing where you fix them into 4 buckets. It's going to be very much where it depends a lot on what you're trying to present and how you're doing it. So for the abstract here, let me read this. Consider the following parallel scheduling problem. Let M and M be the number of parallel machines and jobs respectively. In addition, if job J is scheduled on machine I, job J takes Pij time units on machine I. Given n jobs, the goal is to schedule each job on a parallel machine non-preemptively so that the schedule containing all n jobs has minimum makespan. Like I said, that's a jargon term. This is a classic NP-hard problem in scheduling theory called the makespan minimization on unrelated parallel machines, commonly abbreviated as RCmax. That's some notation there. RCmax. Currently, the best approximation algorithms for RCmax have approximation ratio 2. Despite over 25 years of being intensively studied in the literature, finding an approximation algorithm with approximation ratio better than 2 for RCmax still remains an open problem. In response, researchers have focused on NP-hard special cases of RCmax that share the same inapproximability bounds in the hopes to better understand the problem and provide approximation algorithms with improved approximation ratios. 2 such problems are the graph balancing problem and the restricted assignment problem. In this talk, we discuss recent developments in our research for the 2 problems with the focus on when the parallel machines are uniform, i.e. every parallel machine has a speed. So that's a lot of stuff there, right? Everybody can agree that there's a lot of stuff going on in this abstract. But it's also, you'll notice it's not a very, I would argue it's not a very deep abstract. It doesn't go very deep. But most certainly it's very specific, right? So So there's also a mixture of jargon terms, like my previous example. There's some jargon in there. So for those never heard of the word jargon, it's a technical term that generally is accepted among a research community that might mean something very specific, but to people outside of it, that may be a little bit trickier to understand unless you define it for them. But what I want to do is let's walk through the 4 parts here again. So does anybody have any ideas for what the 4 parts might be? Any ideas? So I'll give you a heads up that there seems to be a lot of setup in this abstract, right? So is any ideas what might be the introduction, or maybe we'll just stick to introduction/motivation. Any ideas? Well, let me get started here. So let's take a look at this. So one thing that you'll notice right away is that, like I mentioned near the beginning of this, that in some areas it's often appropriate to talk about what the problem is that you're studying. This problem, by the way, is a very well-known problem among combinatorial optimization researchers. A lot of people that study like scheduling will know what this problem is. It's a well-known problem. But most certainly, I decided to introduce it to the audience, my reader, my abstract, because I didn't necessarily know that they would know what NP-hard means and all these things, because they might be undergraduate students, for example, unless they're, say, upper year. So what I did is I included all of this. Now, so notice it keeps going, right? Like it just doesn't stop. Here's an introduction. Here's this. It kind of keeps going here. Abbreviated as RCMax. So all of this seems to be kind of an introduction. So this seems to be an introduction, right? All of this. So we're going to see that this part probably we can crunch down, because there's a lot of details here that maybe I don't necessarily need to be introducing in the abstract, especially at our level where we're dealing with. The reason why, by the way, I also wanted to show this to you is because I also did write this when I was a graduate student. So I thought I would show you something that I did when I was undergrad and see how we could improve it. So here we go. So now that seems to be a good idea for the introduction. Okay. So notice the next part talks about what's currently been done. Currently, their best approximation algorithm for RCMax have approximation ratio 2. And it talks about, despite 25 years of being intensively studied, in the literature, finding an approximation algorithm with approximation ratio better than 2 for RCMax still remains an open problem. So do you see how you can use the literature review to contextualize what you're currently studying? So it openly presents what would be a nice catcher's mitt for what you would like to talk about. So notice that the literature review in this example, it's kind of like the other one. What it does is it sort of sets up a scenario for which I can come in and talk about what I'm interested in. So I think that this part here seems to be appropriate to label as like the literature review. But keep in mind, it might be just that you're presenting just a general idea of what's been done, so that you can come in and frame what you're currently doing. In this sense, I'm actually literally talking about a problem that has been intensely studied. So it might make more sense to be a bit high level about this, as opposed to very narrow. So in response, researchers have focused on NP-hard special cases for RCMax that share the same inapproximability bounds in the hopes to better understand the problem and provide approximation algorithms with improved approximation ratios. So notice here that I don't claim that this is what we're doing, but it's implicit that that's what we're actually studying if you actually take a look at the title of the talk. Approximation algorithm for scheduling unrelated parallel machines. And the abstract clearly contextualizes this as me saying, hey, look, this is really tough, so let's study it some more. So you might ask, okay, so what's like the methodology and all of that? This sentence actually lays out what the talk is actually about, if you think about it. So it's saying that researchers have been focusing on these special cases of this problem so they can better understand it. So let's say two such problems are graph balancing and the restricted assignment problem. Now, I think that those also can go in here too, because those are a couple of specific target special cases. I think that one's a little bit unclear where it might go. That's one sentence. But there's your third chunk. The final chunk is it says, in this talk, we discuss recent developments in our research for these two problems with a focus on when the parallel machines are uniform. So this is actually a description of actually my main results, because this talk actually included several results in it. And some of them weren't mine. Some of them were things that have been done up to that point, because the point of the talk was to give an idea of what has been done up to that point. So I have 4 pieces right here, but you'll see that you might find some of the ideas I have here pretty helpful if you actually think about it. Say if you're doing more of a broader talk about a given area, you might find some ideas here for how you might go about it. But this is most certainly a more formal talk. So like this is like some pretty hardcore theoretical computer science stuff. But it's a pretty good, some people really liked the talk. It was a pretty good, it's an algorithms talk. So naturally, we need to find a way to improve this. So let me use the last bit of our time here to talk about how we can refine this. Then we'll talk about how we can think about our title. So here's a couple of tips I have here. So the first thing that I should suggest is that this first part, it's way too long. It's just way too long. Like, do you think that, like, say if you've seen this, like, you can generally get a feel for what the problem is about, right? But do you think really me going into all these details helps me understand the last bits of this abstract? Yes or no? Well, of course, generally it does, but I have a question for you. Is it sufficiently needed for me to understand the rest of the abstract? Other than, oh yeah, there's this thing called make-span minimization on related parallel machines, and it's abbreviated that. Most of this other stuff doesn't seem to actually come up anywhere else in the abstract, right? So the big thing is that, like, the one thing you have to keep in mind is if you need to go into that level of detail, you might have to. But most certainly here, I'm studying a well-studied problem, like a problem that is well-known, like the traveling salesman problem. So oftentimes, if you're talking about a problem like that, you don't necessarily have to introduce your audience to it in an abstract like that, unless it's absolutely a new problem, and it may make a bit more sense somewhere else in the abstract. Here, notice that I nowhere use I, J. Notice that I don't talk about jobs or machines anywhere later on, right? So it seems like I don't really need to go into this detail. Instead, I maybe should introduce the idea that we're studying a NP-hard scheduling problem, and it's called make-span minimization on related parallel machines. Maybe I should focus just on that, as opposed to all these little bit of details about defining it. This might be more appropriate for an abstract of a research paper, which most certainly it is, but it's just maybe not so much if we need a short abstract for a talk. So, yes. Yes. Yeah, no. Well, I like that suggestion. I agree with you, especially that we only have 120 words. I agree with you as well that if I know that we're dealing with a general computer science audience, they might be able to accept the fact that there's this problem called make-span minimization on related parallel machines. It's a well-studied problem. So going into these details, none of this gets used later. So I agree with you completely that we don't need all of this setup. This might be a little bit more appropriate in a context like a research paper where bringing up this notation might pop up in some of the main results where I and J might get used or these processing times might get used. But just like I would like to analogize it to like writing a computer program. If you write up something that doesn't use variables that are required to describe something, why have the variables in the first place? Same idea here. So, yes. Yes. Yes, no, definitely. Yeah, no, that's really where I wanted to go with this, is that I want you to be sufficiently comprehensive. So so given the fact that you know your audience roughly. We talked a little bit about with some of our other classmates about general kind of background where everybody sort of is, and we have an idea roughly where people are. So if I know for a fact that say almost everybody knows about like what NP hard means, then I can use that term. Most likely it's okay. In some jargon terms, you can get away with those if it's very common in that area. But most certainly, I should need to go into all these details because I never used them anywhere else in this abstract to better understand any of the discussion points here. So let's refine this now. I was going to suggest, here's a suggestion I have, and I thought about this carefully myself because I was like, okay, I want to get this word count down. So walking you through the same kind of mentality here, well, think about it. There's really one sentence here that actually is only relevant to everything else later on. There's a sentence right here. It says, so this is describing what the problem is. But the thing is, there's this one sentence that says, this is a classic sketch this should say NP hard. My apologies. Classic NP hard problem. Like you can see, I was trying to find his face to put everything here. This is a classic NP hard problem with scheduling theory called the makespan minimization on unrelated parallel machines, commonly abbreviated as this. Well, what if I take that and I adapt it? Because that seems to be what I need to introduce the reader to, is that's the thing we're considering. So here's a suggestion how we can trim this down considerably. So this is one suggestion. We're going to see a few others. I know we're going a little bit longer here. Hopefully this is okay, everybody. I'm not going to be much longer than this. So we're just going to go through this example, and then I'm just going to give you some tips on coming up with a title. So I'm just going to, let's just get rid of everything that is associated with this one compartment. So when you put in bids like this, it makes it a little easier to compartmentalize your thinking a little bit. And if you're not happy with it, you can always come back to it and say, hey, look, I don't really like the way I presented this one thing. But I like your suggestion. Let's do something a bit more. So I'm going to put much less in this box here. So here's a suggestion. Instead, I say we consider a classic NP hard scheduling problem. Called makespan minimization on unrelated parallel machines. Abbreviated RCmax. So this is what I'm going to suggest we replace all of that with. Do you notice that if I just have this, it doesn't actually make any less of this, like any of this less understandable? Does everybody notice that? Like everything after this, the only thing I use that's from this sentence is RC max. Does everybody notice that? So I introduce what the thing we're going to consider is. I tell you about it, and then I tell you what researchers have been doing, and then I tell you about what we're going to do with it. So doing this alone actually cuts down the word count considerably. So this is one way you can always trim things down, is you could trust your audience to understand that you're studying a specific problem. So if this is an application you're focused in on, maybe there's a specific kind of application you're interested in, and you can introduce that there is this type of application that you're that there is this interesting application that you're studying, and this is one element that you're focused on. Then you could proceed to your next thought. There's a lot of different ways you could frame this, but most certainly that's one. Let's see what so that's one suggestion I have. Is there any way, so another idea is that we could try to carefully drop words here. So I want to show you an example of how I might do this. So let's see, currently the best approximation algorithms for, let's just say RC max, I sort of erased part of it, RC max, have approximation ratio 2. Despite 25 years of being intensively studied, finding an approximation algorithm with approximation ratio, instead of being better, I thought it would be more useful to actually use a more specific word. Instead of using better, I will use the word less, less than 2, for RCMax still remains an open problem. So in response, researchers have focused, so I would like to get rid of these two words and try to contract it into a single one. So instead of in response, researchers, okay, I'll keep have. Focused, see, I think I've already used the word focused at some point. If not, I think we can use a much more specific technical word here. Let's use the word investigated. Have investigated, and let's get rid of the word on. Have investigated NP-hard special cases of RCMax that share the same inapproximability bounds in the hopes to better understand the problem and provide so notice that I have with improved approximation ratios. Now, technically speaking, now for those that are not familiar with the area of approximation algorithms, normally when people say improve, like approximation algorithm with an improved approximation ratio, that's all they're saying is it's a better approximation algorithm, right? So I'm just going to get rid of some more words by just simply cutting out, so instead of having with improved approximation ratios, keep in mind, I could get more specific in the actual talk. Provide improved approximation algorithms. So do you see how you can go through this very delicate process of trying to find ways that you can be sufficiently comprehensive to what exactly you want to talk about, but you can trim things down a little further. So I think, let's see what else I could do here. Two such problems are, that sentence okay. We discuss, so instead of saying in this talk, I want to get rid of a word here. So instead of saying in this talk, I'll just say we discuss. So I'm just going to capitalize the W on we, because it's implied that that's what we're talking about, right? We discuss recent developments in our research for these two problems, especially now you'll see that I use the word with a focus. I can cut this down even further. So instead of using with a focus, I could say especially. So instead of with a focus on, I can replace all of that with especially. especially when the parallel machines are uniform. So do you see how you have to, like, this is what I mean by cutting. So what's going to happen is you're going to have this really wonderful abstract you start off with. But the thing is, you want to get it so you trim it down. And the biggest part about it is finding ways you can take words that are several words together that have maybe a different word you can use to abbreviate it even further without losing the meaning of what exactly you're talking about. So just first brainstorm out an abstract, think about how you can organize it into those 4 parts, write your perfect abstract, so I'll use quotation marks when I say that, and of course after that, once you have identified those parts and you've written it out, once you're really happy with it, then you go in like a Tonka truck and you plow this sucker over and you try to improve the thing. So you kind of go in there and you just really get your hands dirty to see if there's any way you can refine or sharpen it. In particular, if you have to get down that word count, you might sit there and really have to think carefully about how you can contract sentences a little further. A couple tips I can also give you, I don't have them mentioned in here, but a couple of tips I can also give you is that if there's an acronym that you'll use all the time in your abstract, for example, you'll notice I use this symbol, the sequence of symbols called RCMax, rather than make span minimization on unrelated parallel machines. I've saved myself some words every time I write that. Does everybody notice that? So that's another thing you can keep in mind if you find yourself needing to really save space. But obviously don't go too wild with it. Otherwise it's just going to turn into like you're writing out the ABCs and that's not very fun to read. But most certainly just keep in mind that you want to make sure it's readable, comprehensive enough that if somebody were to read this, be like, okay, well, that sounds kind of interesting. But most certainly, there's always ways you can kind of take it and tailor it to your audience. And that's really, at the end of the day, who you want to focus on is comprehension, but comprehensive only enough. Detailed enough, but not too much. Because you're going to find that this count is going to go away very quickly. 120 words is not a whole lot if you have a lot to talk about. But one last thing, so I thought I would talk a little bit about titles. So before we proceed, are there any questions about just generally about abstracts? So you're going to find you're going to definitely go through a process like this. I know that I like to show this so that you can see, hey, look, Dan, like we just did it to Dan's work. So you could do it to everybody's work. But yeah, no. So if there aren't any specific questions, I thought I'd talk a little bit about making an appropriate title. Now, the biggest thing that you need to know about with making a title is that you have at most 10 words for our seminars. So at first, this doesn't sound like it's going to be too bad, but it depends a lot on your area. For example, I've had papers that are much longer than 10 words on them. But there's other ways you can get around these kinds of things. Think about generally how you want, what's the main theme of your talk? Sorry, I was getting very excited there. So remember that you want to contextualize the abstract so that, one, you can use the title as a vehicle to help understand your abstract, but at the same time, you can also use it to advertise your talk. So for example, if you come up with a nice creative title, it could be very, very tempting to come and see it just for the sake of that. Just to give you an example of what I mean, it's not the first time I've ever come up with a talk that's used a slogan or phrase that's from popular media. Sometimes you can work things like that into a technical talk. So I'm trying to remember the exact name I had for this talk. But it was something, it was a play off from The Wizard of Oz. There's this phrase, lions and tigers and bears, oh my. I gave a talk that pretty much had this same setup, but it was that the talk was actually about 3 different types of constraints for scheduling. And so every one of them, like the lion, the tiger, and the bear were all different constraints that I was going to talk about. So you got to get creative with the title. So if, for example, it's for a paper, maybe it's appropriate to give the title the same as the one in the paper, but most certainly you also got to think about what might contextualize your talk in the more appropriate way so that it makes it easier to understand what your talk's going to be about. For example, in my title here, I have approximation algorithms for scheduling unrelated parallel machines. So notice very quickly that it helps contextualize everything I'm going to write right here, right? So it's about approximation algorithms. It involves scheduling these things called unrelated parallel machines. You don't even need to know what an unrelated parallel machine is, but most certainly you can see that, okay, it's about something about algorithms, and there's something about scheduling, and then there's something about this thing called makespan, and then there's something else in here about that they've been trying to get these better algorithms for some time. That sounds kind of interesting. Maybe Dan has something interesting to tell me about this. Perhaps. I don't know. But the point here is just try to keep your title simple, to the point, but comprehensive enough that you can just simply give somebody the title and be like, okay, that's roughly what the talk's going to be kind of about. But at the same time, look at it as an avenue to, I don't like using the word market, but most certainly if you're in the avenue of doing research in a conference setting, advertising the title, like making your talk something very marketable in terms of, oh yeah, that looks like a fun talk, I want to go check that out. That's something to keep in mind, especially depending on which circles you're in for your research. Sometimes people like tongue-in-cheek titles for topics in different circles. Some prefer really kind of stale, but most certainly meat and potatoes and legit research titles as well. Both of them are fine, but you just got to make sure you read your audience appropriately when you do things like that. But the big thing, so I just want to, just for dramatic purpose, just make sure I got everything here that I wanted to say about it. I'll read the final sentence I have for dramatic purposes. So a title can thought to be like a very short description of your whole talk, tied down. So that being said, that's really all I have to say about giving a title or presenting a title. So just think about what best represents your work and what the theme of the talk is about. So that's really one of the big things you're going to really kind of tell about a good title, is it really just hammers in what the talk is going to be about. So are there any questions about formulating a title? I'm really happy to answer any questions. Coming up with a title isn't sometimes a very easy thing to do. Sometimes it's really straightforward because it just sort of falls right out of what you're studying. But other times it's just like how can I make this so it's a little bit easier for people to understand? But yeah, no, excellent. No, thank you very much. Yeah, no. Either way, what I'm going to do is I'm going to stop the recording here because that's everything I have to say. But just remember the deadlines. So we're going to be aiming for the end of June 15th to get the abstract and title submitted. You'll be submitting this over your courses. There'll be a form on your courses where you can explicitly submit it. And if you have any questions or anything while you're preparing this stuff, I'm very happy to discuss these things. Whether you need some tips or you're not sure about anything, just let me know. I'm usually very happy to reach out and get help from. One other detail I need to bring up is that technically speaking, you know, on the course website, you'll notice that the scheduling for when, if say for example, you can't pop by my office hours and you want to come meet with me, I set aside Mondays. So if you just send me an email and you want to meet with me outside of the office hours, I also will try to make sure I'm available then. But note that Monday next week, I think, is Victoria Day. So I don't think the university is open on Monday next week. So just keep that in mind. But I'll try to make sure I'm available. I'm usually pretty easy to reach over email. So that being said, I want to say thank you very much and have yourself a beautiful day. And thanks for your patience, by the way. I appreciate it. I'll see you later. Hey, no worries.